Hello everybody, today we're going to explore how the world could change if in 2 years' time, gravity switched from being an attractive force to a repulsive force. In case you don't know how gravity works, it's one of the fundamental forces of nature that keeps the universe in order. It is a force of attraction between all objects that have a mass, and it is responsible for many of the fundamental aspects of life that humans take for granted. Gravity keeps humans from floating out of Earth's atmosphere by providing a force on them when they do things like jump. Additionally, gravity is the force responsible for the orbit of all of the planets in the solar system around the Sun, and responsible for the Earth and the Moon's orbit of it. So this begs the question, what if the force of gravity were reversed? How would everything change? Well, due to gravity's fundamental role in the universe, if it were reversed, everything would change. For starters, let's focus on life on Earth and branch out. Since gravity is now repulsive, anything not providing a strong enough resistance force to the force of gravity from the Earth would be pushed away from the planet. This would cause not only humans and animals to be propelled into outer space, but also all buildings and plants whose foundations or roots are not strong enough to stay in place. How about we dive deep into the reasons behind this? The reason that things like buildings and plants seem like almost a part of the Earth is due to their general net force of zero. As Newton's first law explains the property of inertia, such that an object at rest will stay at rest, unless acted on by an unbalanced force. In general circumstances, buildings and plants have no net force on them because the force of gravity is cancelled out by forces in the opposite direction, like the normal force. But if gravity changed direction, the net force would no longer be zero. This means that these objects would experience an acceleration according to Newton's second law, F net equals ma, meaning that the objects would experience an acceleration in the direction of the net force on them, in relationship based on their mass. Since the net force on these objects would be basically just the force of gravity, which can be found as mg, the mass of these objects does not matter and they would all travel with roughly the same acceleration. Newton's laws explain why things like houses and plants would be sent into space if this change of gravity happened. This means that even if humans found a way to stay on Earth, maybe by something like a jetpack, they would struggle to find food because most plants would be gone or not grow the same way, and plenty of new ones would likely have even more challenges. Additionally, since structures would experience a force of gravity pushing them away from the Earth, they would be much weaker, and the ones not immediately sent into space would likely eventually be so. However, worrying about how to survive with the changes just from Earth is sort of pointless because the effects of the change to gravity would extend far beyond the singular planet. Since gravity exists between all things with mass, all galaxies, solar systems, stars, planets, and moons would all repel each other, and everything would push apart. Of particular note, the Earth and the Sun would begin to travel at immense speeds apart from each other, and the Earth would no longer get all the resources it needs that the Sun provides. The Sun makes life possible on Earth due to the light and heat it provides in the form of solar energy. If the Sun were gone, it would cause all life on Earth to cease to exist. Plants would no longer grow. Humans and animals would begin to freeze and starve, and all life on Earth would figure to be snuffed out. Even if humans could manage to stay on Earth, it wouldn't do them much good. But you're probably thinking, wow, this is all such a bummer. Thanks for sharing that if gravity were reversed, everybody would be doomed. Well, this is probably true if gravity changed with no warning, but if there were enough notice, I have a plan. As previously noted, gravity is a relationship that all things with a mass have between each other, and we can use that to our advantage. Again, suppose that the force of gravity will be changed to be repulsive across the universe in 2 years' time, and let's brainstorm some plans. The common ideas that come to mind might include, why don't we just tie a rope to everyone, that way they're attached to Earth? This would be an interesting solution, but the problem is that the properties of tension forces would make this plan simple to think of, but riddled with problems in its execution. Since tension forces only act when a string is extended, they would not prevent people from being pushed off of Earth's surface, but merely keep them at a fairly close distance, which would necessitate some sort of pickup crew. Additionally, these ropes would cause a lack of mobility for all people, since you would be unable to move any farther than the length of your rope. However, the biggest issue with this solution is how it fails to do anything about losing the Sun. Or how about everybody gets an emergency jetpack or something? That way they can launch themselves back to the Earth if they start to float out. Jetpacks interestingly bring up Newton's third law of action and reaction forces, as they use this principle to propel people in a specific direction. While normally jetpacks expel high-pressure gas downwards, the important thing is that they send this gas in the opposite direction to which the user wants to go. Newton's third law describes that for each action force there is an equal and opposite reaction force, equal in magnitude but opposite in direction. But again, this solution does nothing to replace the Sun. These solutions fail to consider making life on Earth possible and sustainable. And sure, maybe they could help humans last a few minutes, hours, days extra, but I'm not sure exactly which one it would be. But looking at these attempted solutions helps to display the two main issues that need to be addressed. Number one, the force of gravity will push everything, including humans, plants, animals, and houses, away from each other, along with the sun. Even if problem 1 can be solved, problem 2 is losing the solar energy from the sun. It would prove fatal as well, and all life would no longer be sustainable. After considering these problems, I've come up with a solution that addresses both of them. Alright, here it is. Drumroll please. Around the Earth with a huge dome. And let me explain how this solution addresses the problems that we've diagnosed due to the change of the force of gravity. To be more specific, this needs to be a hollow sphere which is twice the mass of Earth, a massive 1.196 times 10 to the 25 kilograms. For this situation, we will neglect to focus on the logistics of gathering the matter to create a sphere of this mass, but just assume that enough materials are able to be found. In terms of the manufacturing, let's suppose that this sphere was assembled in parts, so that it's easier to assemble when it's brought out nearly to space. The idea behind this concept is to counteract the change in gravity that is experienced within Earth's gravitational field. If the distance from each person to the center of the Earth is equal to the distance to the center of the sphere, this plan works. We're going to be looking at the force of gravity which would be experienced by the approximate average adult, someone with a mass of, let's say, 70 kilograms, using the universal law of gravitation to see the force of gravity each body, the Earth, and the shell would exert on this person, and the total effect that the person would experience due to these forces. We can solve for the force of gravity exerted on this person by the Earth, using the mass of the Earth and the radius of the Earth and the mass of the human, along with the gravitational constant, using the universal law of gravitation formula. By plugging the information into this, we can find that the force that gravity exerts on the average human, the gravity from the Earth, is 686.4 newtons, or to significant digits, it's 686 newtons, which is away from the Earth. And then using all of the same information, except for a different mass, which is the mass of 2 times the mass of Earth, or the mass of the sphere, we can plug in the information and solve for the force of gravity the sphere exerts on the average human, which is 1,372.8 newtons, or 1,370 newtons towards the Earth when rounded for significant digits. With all this information that we've just found, we can find the total gravitational force that the average human, or this average adult human, will experience. And we can do this by knowing that the total gravitational force is just the two forces added together, and if we pick a positive direction, since they are collinear, we can find that the total force is 686.4 newtons, but the decimal places are non-significant, so we can find that the total force of gravity is 686 newtons towards Earth. And then, using this information and the fact that mass times the gravitational acceleration is equal to the force of gravity, we can find the acceleration due to gravity. When we divide by the mass of the average human, 70.0 kilograms, we find that the gravitational acceleration is 9.8 meters per second squared towards Earth, the same as it currently is. The way in which this sphere acts causes the acceleration due to gravity to be equal to what it is in the present, where gravity is an attractive force. If we look at how an object would slide down an inclined plane, with a more thorough display of the forces acting on it, we can see the way objects will move after the change. The same as right now. If we look at this diagram, we can see a 5 kilogram object sliding down an inclined plane, which is at a 27-degree angle. We can see 3 forces acting on it: the force of gravity from the Earth, the force of gravity from the sphere, and the normal force. We can rearrange this diagram to show more forces and show the force of gravity acting in x and y directions, if you suppose, in their relationship to the slant of the plane. We make it so that the direction that the object is moving is the x direction, and we can see how the force of gravity and the normal force are related to each other. These triangles that are made with these relationships are at a 27-degree angle, which is shown by the relationship they have with the angle of the inclined plane. Now let's use this diagram and this information in order to solve for the acceleration that this object would experience. We can see that vertically there will be no acceleration because you can see that the force of gravity from the Earth in the y direction and the normal force combine to equal the force of gravity in the y direction from the sphere. Then we can work on it in a horizontal plane, or along the ramp, really, and we can see that it will be the difference between the force of gravity in the x direction from the sphere and the force of gravity in the x direction from the Earth. Using trig ratios, we can find what these x values are. Since we're looking for the acceleration, we can factor out the masses from all sides, since it will be the same mass of 5 kilograms, and we can make this only based on the accelerations, accelerations due to gravity, and then use that to find our acceleration. Plugging this into the formula using our trig ratios, we're able to find the acceleration of the object on the block and find it to be 4.49 meters per second squared, or when rounding to significant digits, 4.4 meters per second squared down the ramp. When examining this whole process of the calculation, you can find that it works the exact same way as the current inclined plane question would work. So that means that there's no change in the way that an object would go down an inclined plane after this solution is put into place as it would travel in present day. This means that problem number 1 has been solved. However, I don't think we can solve problem number 2 in the same way, by changing the force of gravity. We need to attack it differently. The key properties of the sun are related to its solar energy. It releases solar energy through radiating it towards Earth, and there is gamma and UV radiation and rays that are a part of this. The solar energy is key for sustaining all life on Earth, including plants and humans. And we need to figure out how to implement these properties into a more synthetic and human-made form. This synthetic sun would then orbit around the Earth on a track inside the giant sphere, being the distance of the Earth's radius away from Earth. This artificial sun would have to be a fiery ball of light that would implement these previous qualities that the sun has that we discussed. Of course, this means that the sphere would need to be made of extremely flame-retardant materials with an extremely high heat capacity, but it would be more manageable because of the distance between it and the Earth, meaning that the new sun would not have to emit nearly as much energy in order to have the same positive effects. Let's assume that this new sun is basically the same distance away from the Earth as the radius of the Earth. An interesting thing to look at is how fast the new sun would have to travel in order to orbit the Earth once each day, assuming it can go in a path along the circumference of a cross-section of the sphere, since without an unbalanced force, the Earth will continue to rotate. With an understanding of centripetal force and how it works, we can find the speed of this object since it's moving in a constant circular motion. Using the period being 1 day or 86,400 seconds, and the radius being 2 times the radius of Earth, of the circle that this motion is taking a part of, we can find the speed that the sun will need to be moving at. Subbing in the information, we can find that the speed is 927.6 meters per second, and that means to significant digits, the synthetic sun must travel at a speed of 930 meters per second, or 3,300 kilometers per hour. Wow, that's really fast. Well, we did it, everyone. The Earth is saved! Problem number 2 can be checked off using this synthetic sun. Well, who would have known that if gravity changed to a repulsive force in 2 years' time, all we need to do is build a huge sphere around the Earth and have a synthetic sun that orbits around it. Well, that's it for today, guys. Thank you so much for watching. Have a good day. Bye.